So moving on to the next example, in the rectangular prism, express each of the following scenarios in terms of vectors x, y, and z. Now, we got this rectangular prism here, and its vertices are labeled A, B, C, D, E, F, G, and H. And then we have these vectors, x, which is going this way, y, and z. I drew them in different colors so you could see them a little easier. And then we have to take each of these vectors and express them in terms of x, y, and z. So let's start with the first scenario, this vector AC. Now this vector AC, its tail would start at A and its head would be at C. So it would be like this. So how can we go from A to C? Well, we can start with this vector. We can go from A to B. Okay, so we could take vector AB, and then to it we can add vector BC. And then notice how these middle B's would cancel out and we would just be left with vector AC. Now vector AB is the same as vector X. And vector BC is an equal vector to vector Y. Because it's a rectangular prism, the lengths of these two sides are equal, so the magnitude of these two vectors are equal, and the directions are equal as well. Even though they don't start at the same point, their magnitude is the same, direction is the same, so it's an equal vector. So BC, vector BC, is equal to vector Y. So AC we can rewrite as x plus y. Now let's move on to the next vector, this vector BA. Now BA, if you remember, the tail would start at point B and the head would be at point A. So the tail would start here and the head would end at A. And notice how vector x, the tail of vector x starts at A and the head of it ends at B. So it's the same magnitude, but it's going in the opposite direction. So BA we can just rewrite as negative AB. It's the opposite vector of AB. One more time, AB has the same magnitude as vector BA would have, but it's just going in the opposite direction. Hence we add this negative. And vector AB is the same as vector x, so we can just write negative x. Now let's deal with our final third scenario. So we have to express vector BH in terms of x, y, and z. So vector BH, the tail would start at B, and if you think about this from a 3D perspective, we would reach the opposite side. So the tail would start at B and the head of the vector would finish at H. So how can we get from vector B to, vertex B to vertex H? Well, let's say that we go from B to F first. So let's say we take vector BF. To vector BF, we add vector FG. Alright, so far we got B to F and then F to G. And then to get to H, we would have to add a vector GH. So this would be GH right here. So vector BF, if you think about it, that's an equal vector to vector Z because they have the same magnitude, it's a rectangular prism, and they are both going up in the same direction. So BF we could rewrite as vector Z. Now vector FG, this vector here, if you think about it, it's the same, it's equal to vector Y. It has the same length, and it's going in the same direction, so it's an equal vector. So FG we can just rewrite as vector Y. And now vector GH, it would start at vertex G and it would end at H. And if you think about it, vector GH is the opposite vector of vector X. It has the same magnitude. The length of the side GH is the same as the length of side AB. But since this vector is going in this direction and the X vector is going in the opposite direction, they are opposite vectors. Same magnitude, opposite directions. So GH, we can just rewrite as the opposite vector of vector X. So making these look nicer, we would have minus X here. And then if we want to put it in alphabetical order, we could put the X first, the Y, and then the Z vector. Now, one more point I want to make about this third scenario is that we could have took any route to get to H. We could have went from B to A, and then A to E, and then E to H, or we could have went, for example, B to C, C to G, and then G to H. Doesn't matter. We would end up getting the same results in terms of X, Y, and Z.